Hey everybody, so welcome to online class. This video is just a brief tutorial on friction to remind you of what it is, how it works, the equation we use, just so that you all can continue to work through your packet of information. So we're going to cover four things on this tutorial. First, we're going to answer the question, what is friction? Then we're going to introduce the equation for friction. I'm going to explain to you the equation for friction. And then we'll actually do a practice problem from the packet that you all have. All right. So starting off, what is friction? Well, friction is a force that resists motion between two surfaces. All right. So that could be any two surfaces. For example, though, let's say you're sledding down a hill on your stomach on your sled. All right. And you want to slow down. One of the things you do is you actually kick your feet out, put them on the ground, and they kind of dig into the grass as you slowly slow down. Now, the reason that works is because your boots being rough against the ground actually create a lot more friction than the smooth sled surface against the smooth, soft powdered snow. Another example is skating. So like we discussed from earlier this year, the rubber piece on the bottom of your skates, when you're using it and you want to slow down, you press it against the skating rink floor, and this rubber against the skating rink floor produces more friction than just the rolling wheels. All right. And so you're able to stop. All right. So friction actually works because it's a force that's created by two surfaces coming into contact and resisting motion. All right. So now let's introduce the equation. All right, we've seen this before, but the friction equation is F equals mu N. All right, if you all can see that, F equals mu N. Now, mu is a Greek letter. Mu is how we would spell it, but it's a Greek letter, and we'll get into that a little later. And then N is what we call the normal force. All right, so I'll write that down. And again, we'll explain that later too. Now, explaining this equation, each in its part. So force is just like any other force. That's the friction force. There are two friction forces, static friction and kinetic friction. Static friction is friction when an object is still at rest, not moving. Kinetic friction is friction when an object is moving. But for the purpose of the packet, we're only working with kinetic friction. So the friction force is just like any other force. It has magnitude and direction. And friction is a little easier to work with because it always opposes and resists motion. So if an object has a force moving it this way, friction is always going to be working in the opposite direction. All right. Next is mu. Mu is the coefficient of friction. All right. The coefficient of friction is pretty interesting. So it is a lab generated and tested value that describes the quality of two surfaces of two different materials when they're in contact with each other. All right. So I'll say that again. It is a tested lab generated value that describes the quality or characteristic of two surfaces or materials when they're in contact with each other. So this value purely depends on the two surfaces that you have in contact with each other. And it varies based on what those are. For example, if you had a plastic water bottle rubbing against cardboard, that is very slick actually, but it has a particular coefficient of friction. All right. And I'm going to pull out the book. The book actually does a good job. It has a table that actually shows you a couple of those different values. So as you can see, depending on what you're looking for, the values are going to change. All right. Now, mu S means static friction. Mu K is the coefficient of kinetic friction. So the coefficient of friction is different based on whether those two surfaces are already in motion or whether they're still standing still. All right. But the coefficient of friction, as you could see from the table, normally doesn't go above a value of 1. Normally it's 0.75 or 0.5. or less. All right. But this is a unitless value. So when you solve